Yo, what's up, what's up, what's up, everybody? Welcome back. Today we are working on my map. This is a map of Vancouver, and the goal of today is to make it so that when I ask it to tell me how to get from point A to point B, that it doesn't tell me to walk on the street. That's kind of the goal for today. So, our plan of action is approximately that we want to start with making it so that if we look at this street here, it says like, hey, I'm a highway residential. Highway just means street in OpenStreetMaps data. So step one is going to be like, I want to, as someone using the site, be able to like choose traits about things that I care about in some way, shape, or form, right? So I might be on my bike and I might want to say, hey, I'd prefer to go on streets that are cycle ways, as they're called in this thing, or maybe I'm in a car and I prefer to be on fast streets. Maybe I'm walking on foot and I would prefer not to walk on the road at all, right? So that's step one, is to add like costs to different types of streets, as well as like add an ability for us to assign costs to those types of streets. The idea of our path planner is supposed to be that it's going to be highly configurable. So we might have presets that say like, hey, if I'm walking, I probably want to not walk near these streets. I probably want to walk on sidewalks. I probably would prefer not walking through these areas, right? But like generally we want everything to be like ultimately like uber tunable. So that's what we're going to work on first, is like add the interface there. Then we will make it so that the algorithm is weighted for those things. And then we're going to work on like sidewalks. So the hard part of this stream is probably, I was expecting it to be here, right? This sidewalk says I'm a sidewalk, right? But he's next to this thing that says, hey, I'm like a relatively busy street. And so we're going to have to somehow tie this to this. Maybe we'll say we don't want to walk on sidewalks that are within a certain proximity to a busy street, or maybe we will say this sidewalk is part of this busy street and we just won't walk on it at all. There's a couple things that we might try there. Yeah, that's the plan for the day. That's the plan. So let's hop in. It's like this. There we go. There we go. Okay, so step one. Step one is we want, probably in our HTML, something that says like button that's going to be like add filter. Maybe we'll call it a filter. I'm not sure how I want to call this yet, but I'm kind of imagining like, I'm imagining that you have like a button down here and like you press the button and you click this, and like maybe it's like a text box with a button, and here you like type in a like trait that you care about, and here maybe you have like trait cost multiplier add. So you type in the thing, you type the cost and you add it. Maybe actually, the way that this works right now, we kind of hover over something with like the center of the screen being kind of like a reticle that we can like select stuff with, and then we get all of these things. So maybe we can like click one of these. Maybe we like have like a little add button, and then it jumps into like down here with like a number that we can adjust. I like that. I like that. Okay, so let's do that. Let's do that. Like for each element, we're going to add a little add button next to it. So I think these things are dynamically added through JavaScript. The Zig code calls our like GUI abstraction. He says, hey, I'm going to push this tag. Could you like display that on the screen somewhere? And here, all we have to do is say, add is a document create element button. And then what? We have like label is going to be, I guess div is probably fine. This is going to be applied to the label. The div is going to append a child of label. And then here we're going to div append child add. This add button is going to have to do something, but we can kind of figure that out in a second. So add inner HTML is equal to add. Good enough for me. Good enough for me. So if we refresh this now, we do have add buttons on here, but they are also kind of like not where I want them to be. I want them to be kind of like right justified. So let's add like a class label to this, and we'll just call this like a way tag or something. Doesn't really matter. And that'll give us like some CSS attributes that we can play with. Also, it's kind of bothering me. However cool it is that we have this like satellite view now, it is kind of annoying me how slow these are to load in. It kind of like bogs down the performance of the whole app while it's loading. So I might choose to kind of stub those out. Yeah, I do. I think I do want to just kind of disable those real quick. Sorry. I know it's very cool, but I think it is hurting us right now. So satellite.json back. We're gonna make a satellite data JSON, and this we're just gonna write in an empty array, and that should make it so that when we run this thing now, it doesn't try to load all that stuff, and the performance is way better. Okay, we'll come back to that in a future stream. Okay, so now we should be able to go in here, and we should be able to say that we have like this concept of, was it way tag, and we can say like, can we do like display flex? Okay. And then we want like a way tag button to be like right aligned. Can we, oopsies, I didn't mean to close that, fuck. Well, I press Control W every time I want to backspace a word because of Vim, but it's fucking me. So can we like right align flex box item? I don't know how you fucking aligning items in a flex container. Display flex align. Okay. But I want like just one of the things to go. Align self. Align self. Seems right to me. So let's look again. So we have like way tag display flex. I don't know if this is like the stupidest way to do this or not, but whatever. I don't really care. Way tag button align self right. What are my options here? End. No, it's not doing what I want. Not doing what I want. Maybe we want like grid, and maybe we want like, how do you do like grid? How do I fucking do this? We have grid items. Then how do I like set the number of columns? Grid column, grid template columns. Template columns. Then I want like, 1, 1 or something. How do I do this? I want like 2 CSS grid columns. Grid num columns. Grid template columns. Repeat. Oh, 1 FR. I forgot. You have to say that you want the grid column for real, on God, on God. There we go. And then here we can make it so that the button, maybe we like set its width to be lower or something. Or can we like set like expand policy? So we want like we want the thing on the left to be like as fucking fat as it can, right? So can we say like grid item fill space CSS? One for min content. Min content. Oh fuck, I wanted this over here. Oh god. Okay, so this is like min content. There we go, baby. We got there. We got there. For real, on God with the Ohio risk. Exactly. Okay, so now we can add this to our index HTML. FG for foreground, and we slap this shit in here. Boom, boom, boom. And then when we refresh, much better. Okay, now we have to do something when we click the button. Because right now it's just fucking jack shit. Right, so let's see. I think maybe like step 1 would be, it would be kind of nice to like when we add it, maybe show all streets that match that thing. So maybe we like color them all. And I think that that'll be good because that'll give us that'll force us to like interact with ways in that way. Because right now, kind of what we do is we just kind of like render like the world, right? We have this like big buffer of points, and we have this like big buffer of like links between points. And we just say like, OpenGL, could you render this for us? And he's like, all right, good. So now we're kind of saying like, ooh, can you not render these ones? We want to render these ones in a different color. And that means we'll have to like at least figure out how to like interact with them in some way, shape, or form. So is this data from OSM? Yeah. OpenStreetMaps data. OpenStreetMaps data. So when we click add, this has to do something. So on click, something. Who knows what? Oops, wrong way. This is like this. This takes in like an event. Probably the event doesn't matter because we're just gonna bind in like whatever key and value we got here. So sorry, I'm just thinking for a second. Yes, it's fine. So we will say I'm trying to think about like who owns what state, right? Because like the model right now is that the Zig side kind of has like his app state, and he like pushes state to the GUI side. He like throws it over the fucking barrier, the CFFI barrier, which happens to go to JavaScript. And right now he says for each tag, like we'll clear the tags and we'll push the tags. I guess it makes sense for us to follow that pattern where he says like he can choose to clear the state of what's on here, or we could ask, he could either push every once in a while, he could say like, hey, we added this filter, and keep track of that. He could say the GUI, you hold on to that state and like just never forget it. Or he could like reset it every render loop. I think resetting it every render loop is kind of silly. So yeah, I think it makes sense for us to have this like maybe the API is like remove tag and add tag. So these are going to essentially link the internal representation to the GUI state. And so on add tag, it's going to look like key and value and color. But I guess like the internal representation of our stuff is not that like not strings of keys and values for these tags. Like we don't store these things as surface alley. We store these things as like string 45 and string 72. And maybe it makes sense for us to have like an ID of added things. That makes sense to me. Yeah. So okay, here's the vision. We have some words, right? Words. Add button, right? On add, I click that add button, and it comes down here, and instead of an add button, it has like a color picker, right? And I can like click this color picker, and I can choose to display those streets as like whatever color I want. I like that as a version 0 of this feature. That feels good. So on click, we are going to push this key value pair into our app. So do we have references thing? I thought we fixed this at some point where our WASM handlers got access to ourselves. That must be in a version of the code that is not merged yet, which is fine. That's fixable. Instance exports, and this is going to be like add tag, add filter, add I don't know like what the abstraction sounds like here. It's like it's not really filtering, it's kind of like add it's like a way that we care about, right? Which is like not what we want here. It's like monitor way. I think that makes sense. Monitor tag. Monitor way attribute. That feels like the most sane of everything that I've said so far. And he's going to pass in, I guess, the key and value pointers that we got. Um, which is not ideal, but maybe good enough. Maybe good enough. And sure. So he's going to call that. And then in index zig, we need to add that function called monitor way attribute. So this is going to go like over here somewhere with all of the other things that the JavaScript can say to us. Monitor way attribute. It's going to get key, which is a pointer to U8, and value, which is a pointer to U8. And we actually don't need their lengths, because what we can do is we can search our string table for these addresses, and that will tell us the indexes that we need, which is a little shitty, but it's fine. So add or monitor way attribute, which is fine. So now he's got a member function. Pub function monitor way attribute, which gets a key and a value like this. And he's going to like look through his string table. So he needs self on here as well. And he's going to say, hey, I have these strings in my string table. And I guess our string table will just now have a function on him that's like find ID, and we'll pass in self as a const string table, and the pointer and he will return a string table ID. Okay, seems reasonable so far. And what's he gonna do next? Self dot like, what do we have in here? We have data, which is a bunch of pointers. So we just say for self data item, if item pointer is equal to p, return I, which means that we need I here. Rip stream f. Fuck no. It seems, are we, oh yeah, it is like really fucked, huh? It's back? Okay. That's annoying. I think that you probably didn't miss, how much did you miss? How much did we miss? We started adding this like find ID thing, couple of seconds. Okay, that's not too bad. Not too bad. No ID, we can panic here, I'm fine with that. We are so back, we're back, baby! Let's fucking go. Okay, so now we have this like ability to find an ID in the string table. So he's like find ID of k, and const v ID is equal to this, find ID v. It's simple. It's always so simple. This has to say a strong type thing, I think. Probably, because I was strong typing a lot. No, this is not strong type. This is just a type alias, so we don't have to do that. And then I guess now we say like self monitored attributes, push append. I can't remember what is in this language right now. I think it's append. And we just say k is equal k ID and v is equal to v ID. Okay. Now what? Unused local constant? I mean, it's definitely used. What the fuck are you talking about? So we need to add this like monitored attributes thing. We do need this. Oh, because I put dot in front of it, like fuck dumbass. That's why. So our monitored attributes is going to be a std array list unmanaged of. Do we have a type for like string table key value? Metadata? No. But that's fine. Const monitored attribute is going to be like key is string table ID map data string table ID, and the value is also string table ID. And so then we just get a bunch of monitored attributes, and it default initialize this thing, which means that we push this thing. We actually need to use the allocator, which is fine. I don't mind. And then this has to return an allocation error, which means that when we call this in index zig, this has to write a catch and stood log error failed to monitor way. There we go. Good enough for me, baby. Now, what do we do with these things? If we want to color them, I guess we like rip our ways. So on function render, we're going to do something like for self ways, we have like a way. What is in a way? Node IDs. I guess it's like self metadata way tags. I haven't really figured this out yet, but it's okay. We will get there. So this is way tag I. Way tags, I guess. So I think this is a double nested thing. Because yeah, okay. So we have tags for this, and then we say for 0 to way tags len. For type safety, it's common to use non-exhaustive enums. Have I seen that pattern? In which scenario? In which scenario? I don't like non-exhaustive enums. Why is the ball machine frozen? That's a really good question. It's back. Const e is equal to enum usize this. No, I haven't seen that. Why would you do that? So you're saying const e is equal to enum usize this. Oh, so that they can't write else. Okay, I do like that. I do like that. So you're saying that I can do like A, B, C. And this is me saying like, hey, you can match against A, B, C, but I'm not promising that there will only be A, B, and C. Is that what I'm saying? What you're saying? Oh, no, you're saying that you can... This is an alternative to strong typing. So you can use this thing like it's a usize, but it will not interact with anything else. So it's probably very similar in like the... I see. I've not seen that pattern, but it does make sense. I can see that. We'll call this tag ID. And then, so const key of this is equal to way tags 0 tag ID, and the value is like this. This is kind of like weirdly structured in the metadata, so that's kind of why we have to do it this way, but that's fine. And then we'll say if monitored way attributes, I guess we're kind of going to go by attribute. So for each monitor attribute, this is going to take like monitored. We iterate over every single way. That doesn't sound right. What did I just do? This feels stupid, but maybe we do the stupid thing first, and then we will optimize later. So for each attribute, we look for the ways that are associated with that attribute, which means that here we have to say if k is equal to monitor.k and v is equal to monitor.v, we add this way. So here we're gonna have like an array list. So this is gonna be like ways for attribute. Ways for attribute is like an array list of way ID, I guess. And then here we say like ways for attribute append I, like this. Okay. Now what? I'm just gonna catch panic here for now because I don't want to deal with it. But this is not good. It's fine. We'll fix it later. Fix me errors. Then at the end of this, we can like iterate over all ways and render them. I guess. And I guess like this is kind of like static data. So we could kind of do this. We could do this one time on when the person clicks add. That's when we should run this code probably, instead of on every iteration of render. But that's okay. Oof. I must have done something really stupid because we lost 100 viewers. I shouldn't look at that. Probably from when the stream crashed. Oh well, we'll live. Okay. Sure, so we have now all ways for the attribute, and I guess we need to like render these ways. So what does our like renderer support? What does he support? Let's actually go down here. Oh, it's because my stream actually has considered itself fully restarted. Oh, that's annoying. Oh well. It is what it is. It is what it is. It thinks we've only been streaming for 9 minutes. Oh well. Okay, bound renderer. What are we gonna do here? We have like render points. This feels like what I want. So here, probably what we do is we want to render bound renderer render points. So we kind of want to say like if this way yeah. So if we are iterating over ways, and if this way matches, then we want to render it. So here we kind of like say found is false. Found equals true, break, and we say if found. Apologies for the ad coming up. Twitch auto schedules it after stream starts and I can't stop it. So apologies for getting blasted with another ad. Okay, so here we need to render the point ID. So here we basically say we have a way that we want to render, which is like ways get the way ID. So this is values equal I. And we want the index range of this thing into the index buffer. So where is this thing called? Index range. Index range is probably called by the renderer. Render selected way. So we can just ask for it to render the selected way. And he's rendering it blue right now. We'll allow that for a second just to avoid problems. But it's like bound renderer render selected way. We'll just allow us to pick the color in a second. So this is going to be self ways get I value to I. Okay. So this should, if we did everything right, when we click the add button, we should just get like everything that matches that trait should turn blue. That's what we should get. So if I go here and I say, hey, show me all fucking sidewalks. It did not do anything, but I thought it would. So the question is, why the fuck not? Console? We are seeing self mod is undefined. That would do it. That would do it. So index.js, we want to make sure that on construction of this thing, wasm handlers.modules model. We did fix this. I thought. Hey guys, hey guys. So what's he bitching about? Oh, it's because I typed self instead of this because I forgot what language we're writing. Let's try this again. So here I will say, hey, let's look at all the sidewalks. And instead we got a fuck ton of unreachables, index out of bounds, but that's closer. That's actually like executing some code that we wrote. So why? I mean, we know it's related to the code we just wrote, so big win there. And the question is, which one of these? So way tags, this should be 0.len. That could be it. Triple nested arrays sometimes get confusing. Hot take. Hot take. Okay. Add? Oh, hell yeah, baby. Okay, so there's no way to remove them. But if we go now and we select like, you know, something like, let's try to find like all bike routes instead of found maybe an optional index. I'm going to factor the whole thing out into a function anyways. I'm not really too worried about it. But you're right. I don't like doing that, like that style of coding. I don't really like it, but it's just kind of the quick way to get something up. So here, I want to say, hey, show me all bike routes. Oh, that's pretty good. That's pretty good. And then here, let's maybe say like, is this a main street? Yeah, show me all secondary highways. Nice. And then this is probably a tertiary highway, so we can add those in. And then we can also ask it to display us like, I think that there's like even primary highways, probably like Marine Drive. It's probably a highway primary. Yeah, that's pretty fucking sick. That's pretty sick. And it doesn't seem like performance is like that abysmal, although we could like pre-calculate this stuff. Okay. Highlight key value pairs on map. So I do actually want to keep going on this a little bit because I want to make it so that we can remove those things. So on wherever the fuck we add these things, which I can't remember where that is, monitor way attribute. This should basically say like attribute ID is self monitor attributes items len -1, right? And here I want to say like let's add custom color. Custom color. For the color picker, maybe randomize the starting color. That'd be nice if you don't choose. Yeah, not a bad idea. Not a bad idea at all. So now we're gonna say like, I want to like push monitored way or something, right? And he's gonna take like attribute ID. And I guess he should give him the key and value as well. Give it back. But he does need the length associated with them, which is a little annoying. So here we'll just say k full is equal to self string table get key ID. This is a little silly, I know. I know. But shut the fuck up. There we go. So here we give him the k full pointer, v full pointer. And so now he has this like number associated with this name that he can use. Wouldn't it be nice to color different types of street by default? That way you have a quick overview what is sidewalk, path, by road, etc. I don't really want to hard code specifics, if that makes sense. Like maybe we have like a config file that we set those things up in eventually, but I don't want the code to try to specially handle tertiary streets and stuff like that, if that makes sense. just because I don't think that belongs in the code base. There's like some sort of like a perfectionist like code purity thing that makes me feel that way. Okay, GUI bindings. So we have a push monitored way, and he's gonna have. I guess it's not a monitored way; it's monitored attribute. Push monitored attribute. And it's gonna have an ID as well as all the other stuff. Okay. Sure. Is this not what I typed? This is right. And then in JavaScript land, we have to have like a handler for that. So push. I guess that's probably around here. Push monitored attribute, which has now an ID as well as this other stuff. We decode the key and the value into a string. And then I guess we also do something similar here where I guess we can reuse the way tag class list. Maybe that's a fucking problem, but whatever. All of this stuff, really we should deduplicate all this. So we're just going to put a big fix me dedupe, please. But I'm not going to do that right now. We have the label, and now just instead of the add button, it's going to be like input. And I think it's a color picker. Color picker type is equal to color, I think. I don't remember, but we'll find out. We'll find out. Get monitored way. What was it complaining about? I already forgot. Push monitored way. Strict GUI bindings has no thing like that. Push monitored. Oh, because I named it from way to attribute because I have to save the file before I run it. Turns out you have to save your code. Who would have known? Who would have known? We have to bind that thing. I forgot in index JavaScript. Just writing this function is not enough. We need to make it so that when we create our thing, this kind of gets like this. So push monitored attribute. Push monitored attribute. And probably there's some way for me to like iterate those things automatically, but I don't know what it is, and I'm a shitty JavaScript programmer, so what you gonna do? I wish WASM was easier, man. It's not so bad. I don't really mind it. It's not like any better. I don't think they could. It doesn't feel like necessarily worse than like C bindings. You know, like it doesn't feel that awful. So I add these things, and they're definitely getting colored, but they're also definitely not showing up in my thing. So is this getting fucking called? Console log hi mom. So we add sidewalks. Hi mom is called, but this thing isn't added here. Probably because we forgot to add the div. We probably did forget to just say somewhere that we need to append this thing. So the tags div is not where it goes anymore. This is going to go in like monitored div. If we were scaling things by not worse than C, it is an interesting scale. That's true. That's true. So this is going to go into like monitored div, which means that we need a monitored div here. But I mean, it's just like, there's like a little bit of function binding, but I don't know. It doesn't feel like that crazy bad to me. I don't know. And now in our index HTML, we need, I guess, down here before turning cost, after debug path planning. That feels right. That feels right. Now he's mad because monitor div is undefined, but it shouldn't be. It is true that I did not pass this here. Okay. Hell yeah. Okay, we have the color picker now. Now all I have to do is make it so that when we change the color, something happens. Also, performance here is pretty abysmal, but I'm pretty sure that'll fix itself if we pre-figure out which node IDs are associated with this tag. We can probably do that in one pass up front. Okay, so index.js, which is where we are. On push monitor attribute, we just need it so that color picker on change, we're gonna do something. I keep putting the arrow on the wrong fucking side here because I'm a dumbass. Maybe we'll start with console log ev target value because I don't actually know what the fuck is going on here because I'm not a fucking web developer. I don't know what the fuck I'm doing. We do get a color string, I guess. Okay, sure. So I guess here we must have like something that's like this mod instance exports, and it's gonna be like set monitored color. We're gonna pass in the ID as well as this, but we can't really pass in the string directly like this because it is like in JavaScript memory. So here maybe it makes sense to pre-parse the value. Can we get like input color RGB? Like, is this something that we can extract easily without having to like string parse it ourselves? JavaScript color string to RGB. Like, is this just, I just want something. Okay, so they're just fucking running it by hand. Sure. I mean, not the end of the world. Make it as non-intuitive as possible. Are you a Jira architect is a very funny response to that. Dude, people really hate Jira. It's kind of a shitty piece of software, huh? Trying to be too much at once, I believe. So, I guess we just want like color to RGB. And we're going to take in color and we're going to say strip the first. This is expected to be of RRGGBB, I believe, is what we see here. 7 bytes. Yeah, so RRGGBB, BB, and we're going to say what are like IT is equal to 1, IT plus equals 2 on each iteration, while IT is less than 7. We add 2, and we say that the let const c is equal to IT color slice question mark IT plus 2, and then we can say like c to string 16. Whoa, that doesn't sound right. This feels backwards from what I'm expecting. It does feel backwards. Parse hex string JavaScript. Log number 0x. What if it doesn't? I can also parse int with a base. So we say parse int c base 16. So then we'll say like color is equal to an array. Probably this is const. Probably. And then do you push in this language? Yep. Sure. And then IT becomes 1, 3, 5, 7. Yep. Okay. That sounds right. Sounds right to me. And then here we'll say RGB is equal to color to RGB from EV target value, and then let's console log RGB before getting into the rest of it. Because we like small incremental progress around here. 2736 nan. Super cool. Am I off? Like, what am I fucking doing wrong? What am I doing wrong? E0 1B24. I'm going 1B24 empty string. What the fuck? Oh. I am a dumbass sometimes. You do want your iterator increment to go after you use it, not before. Crazy, I know. Much better. Much better. Okay, so now here we want to set the monitored color to whatever the fuck we got. So this is going to be RGB 0, RGB 1, and RGB 2. And now we just have to implement this side of it. So index zig. What do we call this again? Set monitored color. Set monitored color. And what happens here? We take in the ID R as a U8, G as a U8, B as a U8, and global app monitored attributes at ID color is equal to something, right? So I guess we'll just do RGB or something. Probably like this. I don't know. We'll figure it out as we go. This seems to be items. Monitored attributes ID. Oh, items ID. Oops. Items like this. No field name color. That makes sense because we don't have a field color here, but we will give it a color. Sure. I don't know. RGB. Sure. I don't know. And then on render, on our renderer now has to support like render away with a color. So these come in as floats. Surely this is gonna break all sorts of stuff. So this we had RGB render selected way was like 0, 1, 1. We can probably get away with comp time ints that autocast to floats. I think that's fine. And that's actually the only place where this matters. So now we say RF is, maybe these should just be stored as floats off rip. So that we can just here go like monitored R or color R, monitored color G, and monitored color B. I think that's probably fucking it. So all we have to do now is just when we set the thing in index zig, oh, here we're missing a field color. So here we can just kind of color is equal to undefined. Whoever said make it a random color, did you mean color it with the stack memory at the time of pushing? Because we could do that. That's kind of like it being random if you think about it. And then here, we need to do like function cat u8 to color f32 from u8 is gonna be like float from int c as f32 times divided by 255.0. New exploit identified. Yeah, you could maybe extract some pieces of information about like class state by the color that's on the street. True, but also I don't give a shit. I guess also the random color now is just going to be 0xAAAA because that's how it works in debug mode and safe mode. I'm not sure if it does it in safe mode where it automatically sets everything to 0xAAAA or if that's a debug only thing. I'm actually not sure. I guess it'll become apparent very quickly. I guess also we need to, when we push it to, when we say like, hey, we have this thing, we should probably set its initial color, right? Because right now the color that we see here is not representative, but oh, fuck yeah, dude. That's so fucking cool. So if we want to look at highway paths, we can set these as green. Oh, that's so fucking cool. Wait, that's actually kind of sick. That's actually kind of sick. Okay. Okay. So I think that proves to ourselves that we can interact with these things. I think you can get a random int by taking the address of an anonymous struct var. So and struct var xua is .x. Oh, that's pretty funny. Yeah, that is kind of random. I could also just initialize a PRNG. But I'm not going to do that right now. So I'm just going to throw fix me on this. That is... There's a couple fix me's that we have to do here that I'm not going to bother with right this second. One of them is... This stuff should be... This does not have to be done on every frame. We can pre-find the way indices for each trait and run them all at once. Right, so that's something that we should fix. But I don't want to do that right now. And then the other thing was in GUI bindings. This fix me. This should show the we should feed the initial color. Or we should feed the initial color back to the UI. I think that makes sense. Yep. Okay. But, you know, we have to move on with our lives. So we're in prototype mode. So we'll call this colorways, baby. Big E. Fuck it. Why not? Okay. So now let's actually do the interesting work of trying to adjust the score. So I think this is going to be something like each of these ways should have a field for us to set a cost multiplier. So let's do that. Hold on. Bump, 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 bump. I'm so lost. This file's getting too big. Push monitored attribute. Okay. So here, before the color picker, maybe we give it a little cost. So we add an element that's like input. Cost type is equal to number, right? And then cost value is equal to 1.0 by default, and cost on one JS file equals single page application based. Yeah, exactly. On change, we are going to take in the event, and we are going to say like ev target value. Const on change is stupid. It's cost on change. And we're going to do something like this: mod instance exports set monitored cost, and we'll pass in the ID and this thing. Boom. Simple. Now this way tag class is now no longer good, so this is going to be called like way attribute, monitored attribute, and we can go back into wherever the fuck land, index HTML, and we are going to copy this way tag and make it way attribute, and we're going to have one for real and two min contents. I wonder if you could use cost on crossing roads instead of momentum to achieve better paths. I was thinking about that this morning in the shower, and on foot, I think yes, but I think for driving, maybe not. But for driving, you could kind of do it the same thing where you prefer to work on main streets and then it's fine. Biking, you prefer to work on bike paths, and again, it's probably fine. So I think you're probably right that we might be able to ditch momentum once this is working. And that should make our thing speedier. I think that's worth considering. Uh, okay, so I guess what we expect to see is a little bit of UI change here where we have a number that we can work with. A number. Okay, so here, add sidewalk. And this is a problem. Why is that happening? Did I fuck up the monitored attribute and style editor? It's better. Why is my input color? Did I not? Hello? Did I not save? Oh, I didn't add the thing because I'm a dumbass. So div append child cost. Boom. Boom, boom, boom. Okay, so we add highway footways. Now, oh, but we didn't fix the, this should be monitored attribute, so our HTML needs monitored attribute here. Okay, now please, baby. I guess we just have to manually reduce the width of this, huh? Because this is like fucking stupid. So monitored attribute input. How do you do like type? Number like this? Width like 10 pixels or something? Maybe it's something like that. I don't know. Maybe we should. Okay, that's way too fucking low. So let's just kind of figure out. Guys, am I not supposed to use pixels? What am I supposed to use here? What am I like? Is it like 1 EM or something? Is that what I'm supposed to use? 10, 5. Pixels are fine. All right. Well, I've already said 5M, and I don't remember what M's are, but somebody told me that they're more generic. I like CH. What's a CH? CSS CH. Okay, what are our units? Dude, that's crazy. Centimeters? Okay, relative to the width of a character, relative to the font size. So CH is probably more what I want if I'm doing sideways. Okay, so we add this thing, and if we say like 5ch, 7ch, that does feel more like what I want. I want width of characters is like more reasonable because the font size is kind of more like who fucking knows. The font size units, if I remember correctly, are just like fucked. That's my memory of it. It's just like not normal, not good. This is really fucking laggy. Like holy fuck. So probably the idea of searching every like manually calling a render call for every single way is maybe fucking stupid. Maybe. But we march on for now because I don't really care. Because I think that it's going to naturally fix itself in a second. Because now that we have this like set monitored cost thing, I think that we're going to have to easily be able to go from like point pair to cost or something. So we might have to do some pre-computing anyway. I'm not really sure. Let's see. Let's see. So here he's going to take in a cost multiplier. Is that what do we say call set monitor cost multiplier? I think makes more sense. Is like just a little more clear. And here we say cost multiplier is equal to multiplier. Who's that famous YouTuber? So fucking stupid. There we go. And here, when we set the initial color, multiplier is equal to 1.0. Today, Chrome sucks. Let's let you remake it. It is that feeling of just like this pisses me off. I'll make my own is something that I just feel like all the time. I feel like all software has pissed me off my whole life. And I have massive hubris and think we can do it all the time. We've noticed you appear to be working using a competitor. Yeah, I mean, Firefox is also shit. I guess I shouldn't say shit. It's like a complex problem that's like impossible to solve well. But Firefox is feel clunky sometimes. He's a little clunky. Okay, so in our path planner now, we have to do something. I don't know what yet, but we have to do something. And it's like the turn that we have, like wherever the fuck we find our G-score, this has to be augmented with something. It's gonna be like given the distance between, given like the me to my neighbor, which way ID is like the best. You know, so we have to do like given pair of points, current me and neighbor me. What is my cost multiplier? That's the question that we have to answer. So we need, right now we have like ways map to sequences of points. Right? And we have cost ways mapped to key value tag pairs, and we have key value tag pair to cost multiplier. That's kind of like our current state. How are you defining neighbors? Close to or connected to? Connected to. Connected to. So we need, I guess we just kind of want to like unravel this. So we want to go, we have a sequence of points. We have pair of points. We need to go from here to way ID to key value pairs to multiplier. And I think that this is all not very, I'm trying to think like, is there an efficient storage mechanism for this thing, right? Because my initial thought is, okay, so we store every pair of points in an array, A, B, B, C, right? If we have like C, B, we do not store this one. We swap the order and store it as B, C, right? Because the costs are like bidirectional. And then here, if A, B, say we have like a way A, B, C, D, right now I'm kind of thinking you could store this as like, you know, 1.1. All of these go to 1.1, right? Or this is kind of like a uncompressed version of that scoring mechanism, really, because we actually have that like A, B, C, D maps to 1.1, right? That's kind of the truth here. And even that is a little bit not what we want. We kind of have like A, B, C, D, and D, C, E, F. Both of these guys are like main roads, right? Both of these guys are main roads, and main road maps to 1.1. Now, I think that this is silly to store because any ID that we use for like any way that we store this relationship is just as many bits in memory as this, right? Because like here you would have like, maybe you would have like tag or like tag IDs, right? Or tag pair IDs, right? And this would have like this would be like indexed by usize, which is the same size as a float 32. So like maybe that's fine. So this feels like pretty compressed. Now the question becomes like, is there an efficient lookup that goes from this to this? Like, I'm not sure. DP table. DisplayPort. Dude, if I search this, I'm definitely getting porn, right? Coding. That's. Am I dumb, or isn't just the shortest path algorithm with weights along the node edges? But we don't. We are dynamically assigning the weights. Is the problem, right? So we need to find a way to efficiently look up these weights. Is basically what I'm trying to figure out. Dynamic programming table. This is one of the most helpful visualizations. Blah 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 blah. I'm not gonna learn this right now. My gut says that this is fine. Just going from like point pair to score directly, unless there is an efficient way that allows me to store that this is part of a subsequence of this larger section. You can lazily assign them, right? You should already have main road connected to a node. No, that's the problem, is that we don't have anything connected to nodes. We have things connected to ways, and at this point in time, there is no concept of a way in the path planner, right? Because they're kind of like separate concepts, right? You have like dot, 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 right? And if we're like, we also have the piece of information that that these guys are connected. We've kind of like pre-processed these connections, but we haven't pre-processed any metadata about these connections. So that's kind of the interesting part here, is that like if this edge now has to be multiplied by 1.1, then we have like a problem. But I think it should be fine. I think we just pre-calculate this, and that's not the end of the world. I was the only person that was already done. Nope. Yeah, okay. Yeah, the only efficiency gain I can see here is if we knew we could easily index this, but I think that would require like a hash map or something. Maybe there's some sort of intelligent indexing that we can do that I haven't thought of, but fuck it, we're just gonna do this because that's because that's the easiest thing to do right now. So how do we do that? When somebody assigns a cost, we will have to iterate all ways. We already iterate all ways. We already do that in our render loop, right? We are doing that in here. Here are already iterating all ways and checking if they are attached to that thing. So all we have to do there is figure out which nodes are on that way. So we go like for node pair in way, set cost multiplier of node pair. Simple. That's all we have to do. So where do we store? I think it's in map data, node adjacency map. This is going to be a very similar concept to this. Where we're going to have like node or way, node pair cost adjustment map, cost multiplier map, which could have a more generic name. This is kind of like we could store any data that's associated with two nodes bidirectionally, but that's fine. So we're going to have some sort of like get cost that's going to take in ourself, and we're going to have like A and B, right? We are going to return a cost, which is an F32, a cost multiplier, sorry. In this thing, we're going to have like Let me think for a second. Can we do this as a neighbor index? If we do it this way, then it's really cheap to look up. Like, really cheap to look up. Like, if we do this, we can basically store our storage as like a bunch of F32s and segment starts as a bunch of U sizes. Then here we can kind of say that like, you know, we can store this as like a node 0 has 3 neighbors, 1, 2, 1, 2, and 3, and that will go in storage. And then node 1 has neighbors maybe 2, 3, 0, 1, and 2, right? We can kind of like stash that in here, but then we can also say that like since neighbor 1, 0 has already been captured down here, we delete this pair. And then so here we'll say that our segment starts are like 0 and 3 and 5, right? So we index into segment starts. Lookup is like self segment starts a value plus B, and we index into storage like that. And that is the value that we're returning. Right? Holy, he's reinventing TP. That's really funny. That's really funny. That I mean, I've never been one for like names and algorithms and stuff. It's just like this is what makes sense to me. Right? That's pretty funny. If I like, that's really funny actually. And to be fair, I'm kind of cheating here because I'm not reinventing it right now because I already did this when we were doing the node adjacency map thing. Although I didn't look anything up there either. Okay, so all of this makes sense. So now all we have to do is figure out how to fucking initialize this thing, right? And maybe this get cost should actually return a pointer because that way we can use this when populating the values as well. Right? And now all we have to do is figure out how to like construct this thing. Okay. So what we do right now is kind of on initialization of our app, we have this like big list of connections, right? So we kind of pass over the wire like this buffer of like points, which is like, you know, 0, 0, 1, 1, you know, 2, 2. These are like the points in the map, right? So this goes like 0, 1, 1, 2, 2, right? And then we pass another buffer that's like 0, 1, 2, and then like a terminator. When this says like this line is between draw this line and then break and then move on to the next line. It might be this 0xff goes over here. Minor difference. And so what we do right now is we kind of do all of our parsing of this into like our internal representation in one flow. So we kind of just like walk this and say every time we see an xffff, man, we're on a new way. And then we like look at the points in that way. And that's how we build our like adjacency map, right? Is like on our when we're walking this thing, we have our node neighbors, and just as we walk this thing, we say, hey, we look at the next one and we look at the previous one and we stick those together. So here we should probably do something. We should probably like tack on to that same walk. So we don't want to walk the index buffer multiple times if we don't have to, I think. I assume that in terms of like efficiency, it's faster to do the whole walk at once. That actually might not be true. That might be a bad assumption. But I'm assuming at this point that we do only want to rip it one time. And so if that's the assumption, maybe we'll do the same thing here where we make like a hash map of kind of like node pairs. This is a little semantically different than node neighbors. In that node neighbors is like unidirectional. So like 0 to 1 is independent of 1 to 0. Here, our node pairs, we want to make sure that we are only storing them once per pair, which is not what we see in the index buffer. But that should be pretty easy to fix up here. Node pairs. So what is this? This is for each node, we have a hash set of other nodes. And I think this isn't what I want. I think now in this version, this node pairs thing is like a hash set of node pairs like this. I don't know if that makes sense, but it might. And I think that with auto array hash map unmanaged, this should keep our things in the order that we put them in. Is that true? Insertion order is preserved, right? So as if we just slowly rip pairs into this thing and only insert them if they don't already exist, then we should end up with things in the right order. And we should end up with sequences where the node ID on the left like increments monotonically, which means that we should be able to construct the segment starts. Maybe? I think this makes sense so far. So far, like, it doesn't seem... nothing I've said sounds blatantly incorrect to me. Which means that on in it here, maybe we take, like, node pairs as an array of node pair. And then here we have node pair is equal to a struct of A and B. Yep, and we should maybe just say node pairs is assumed to have A monotonically increasing and no duplicates of B to A to B. And no, yeah. Fine by me. Fine by me. Right, so here, all we do is node pairs push, append, put. Fuck. Wait. Sorry, I'm thinking for a second. I was gonna say that here, if I have to swap the order, we have a problem, right? If we have like, we're going from like node ID 0 to 1, but like maybe we see like 1 to 0 first, but I think, yeah, I guess there's no guarantee that this can't happen. There's no guarantee that the ways can't come in this order, which is a fucking problem. Which means that this idea that they are monotonically increasing is not correct. Which kind of makes me think that we go back to the what we were doing with the node neighbors, where we bucket them. We just bucket them based off of ID, which is fine. So this is node pairs. And here we just say smaller ID. So if I is less than way node ID's len, which I guess is already kind of covered here, we say const smaller is the min of node ID value and way node ID's I plus 1 dot value, and larger is the max. Then we look at node pairs smaller. Node pairs smaller, put larger. Right? That sounds right to me. Now there's no guarantee that these are going to be sorted. But we also don't really care about their insertion order here. So this can just be hash map. I don't think we need an array hash map here. Maybe? Does that sound right? That sounds kind of right to me. And this will just say, like, if the thing doesn't exist, if the thing is already there, fuck it. And because of this rearranging, we should never hit duplicates, which is fine. Okay. Now we have a node pairs. Is gonna be try node. Hello? Node pair. Oh, it's under map data, I guess. Hello, what did I just do? Undo, undo, redo. Map, no, yeah, map data. Node pair cost multiplier map. Node pair costs, I guess we'll call it. Initialized. We probably need an allocator, and we probably want node pairs. Blaze it, I guess. I should stop fucking saying blaze it like I'm fucking. He's so fucking stupid. I don't even smoke weed. I just think it's funny to say blaze it. So this is a slice of stood. Oh, my brain. Auto hash map unmanaged node ID to void. I think is what this thing was. And this returns a node cost multiplier map thing. Then we go for 0 node pairs len. We get a node ID as we walk through these. We have the auto. We have like the node pairs at node ID gives us like a thing. I kind of want just like a contiguous slice of these things that I can sort. Unless they maybe I just like dodge this by using a sorted map type. I don't know if Zig has those in the standard library. Like I don't know if they have like B-tree maps or something like in Rust. I don't see anything that looks to me to be like a sorted hash map. Okay, we're gonna go back. We're gonna go back to the array hash map so that I can just like fuck up its internal storage. I guess we'll do something like a alloc dupe the node pairs at node ID keys. Yeah. Oh, they have a sort method? Oh, hell yeah. Oh, wait, hell yeah, dude. Node pairs, node ID, sort. What does this do? Sorts the entries, then rebuilds the index. I guess I don't need to rebuild the index, though. I wonder if it's faster to rebuild the index or dupe. I'm just going to dupe for now. I feel more comfortable with that because I don't want to deal with this. We'll call this sorted. Is this, and then stood sort mem sort node ID sorted with some less than function. Const less than is a Jesus Christ, my poor little brain, dude. It hurts so much. There's too much going on. I can't handle it. So this is a void and return LHS.value is less than RHS.value. And this is node IDs. Yep. So we sort these things with void and less than. Okay. Chilling. I guess we almost certainly need to defer sorted.free. Alloc free sorted. What a funny way to declare an inline function. Yeah, it is pretty funny. But, you know, it is what it is. I think that it's kind of like indicating that I'm not supposed to fucking do that, but you can't stop me. Can't stop me now. That queen? Can't stop me now, queen. Yeah. Don't stop me now. I was close. Close enough. Because I am having a good time, having a good time. Fucking so stupid. Okay. So now what do we do with these things? We say, we have like our storage builder is an array list of F32s initialized with our allocator. And we also have our segment starts. But these are going to be use sizes. And so here, I guess we are starting with each increment of this. We are going to like keep track of the segment starts. So I guess it's like segment starts append storage items len. Okay, right. So this is going to like immediately shove a 0 in there, which makes sense. Makes sense. Then what? Then for each element in this thing, first time I caught you live in a YouTube lurker till now. Well, hello, welcome, welcome, welcome. Glad to have you. I guess we're gonna look over these sorted, and this is gonna have you know, the other. Okay. And we're gonna have like storage. It's weird that I'm not storing the. There's something missing here, where because like here I need to be able to look up the neighbor index. Oh, but we have that information already. Hold on. Maybe this shouldn't be sorted. This should be in whatever order it's in the neighbor lookup. Yes. Okay, hold on. I wonder if we should be kind of working here just directly from the neighbor lookup. Adjacency map. Okay, I'm gonna comment. Okay, we're gonna comment this out right now because this is sketching me out a little bit. No, we can't. We can't. We almost need to store like neighbors as well. Yeah. Okay, so we're gonna call this score storage and neighbor storage. Uh-huh. Okay. This must be it. So in order to get a neighbor index, we're gonna have this. We're gonna here say const neighbor index is a struct. This is definitely gonna fuck me up later. So this has to be strong typed. This has to be strong typed, or else it's gonna just like absolutely fuck me. And so here we can find the neighbor index by iterating through neighbor storage to find it, which hopefully we don't have to do that much. Hopefully, we'll find out later. We definitely will find out if this is a fucking problem, but for now, we can pretend it won't be. Okay. Now what? Now we say this is the score storage and the neighbor storage. And score storage, append undefined, I guess. I don't know if there's a better way of doing this, but fuck it, I don't really give a shit. And I guess we'll just append with 1.0. Fuck it. Okay, then neighbor storage append other. Okay. Add one gives you a pointer. I think that I do actually want it 1.0 though, because if that's uninitialized, we're still going to use the lookup, I think. So I think 1.0 is fine. But that's good info. Thank you. This is still node pairs. And then this is score storage items len, sure, whatever. This is undefined. Then at the end of all this, I think that we can return score storage is equal to score storage dot to own slice. And the neighbor storage is neighbor storage to own slice, and segment starts is equal to try segment starts to own slice, I guess. I don't fucking know, man. So now we have like somewhere where we can store the costs of these. And I want to see if this is going to make sense here. So in the path planner, this is kind of fucked. So here, we already have this neighbor index concept already, but this is not the neighbor index that I was talking about before. This is like the neighbor index in the bidirectional version. Which kind of feels like... Okay, so we came from this neighbor index. A star node is me, came from this neighbor index. Let me think if that's the same. Otherwise, update neighbor. He has an A star node. The neighbor is an A star node, which is definitely the tying of the neighbor to me. So we do kind of need that info already, and I feel like adding the cost here of searching for another neighbor index lookup is not worth it. It's almost like just storing this cost twice might be better, just to make it so that this loop doesn't have to do more calculations. I guess that will make the cache line, like we're just going to eat the cost of having to look up more scores there. I guess we have to start somewhere. We have to start somewhere. And so maybe we're just getting ahead of ourselves here. Maybe for now, instead of doing all of this complicated bullshit, do we just start with a hash map here? Do we just start with, costs is a std auto array hash map of node pair to F32? Maybe we just start there, because I think that I'm not convinced that this is going to be faster and this is going to be easier to work with. So that's what we're going to do instead. That's what we're going to do instead. And do we want to like lazily initialize this stuff? I think that's probably fair. We don't even need to populate this thing initially, because the assumption will be if we haven't said anything, it's 1.0. So let's just do this. Like, fuck it, right? Maybe we come back to this later, but it's not the end of the world. So return costs is equal to std auto hash map unmanaged. I guess we can let it be managed. It'll be managed. So auto hash map node pair to f32 initialized with alloc, which means that we need a deinit function. That's funny that we spent all that time on that for no fucking reason. Get fucked us, I guess. So this returns void and calls self cost deinit. I guess that's just kind of part of the exploration process, though. That is just part of how it works, right? So we don't have to feel too bad about it. Okay, so here we are going to say self. When you aren't sure how to do something, just do all the ways. Exactly. So self costs. This is gonna have to be mutable now because it might insert the thing. No, we'll have get and put separate from each other. I think that's fine. For weird sort syntax, function less than void i32 and context and sort method should be squiggle, not void. Yep, that's true. That's true. I probably fucked that up. I wasn't really paying that much attention. Why is this not auto-resolve anymore? Something about that doesn't feel right. Because this is node pair, that's why. Self costs. So this is going to be get. And he's just going to get the fucking get it raw, baby. So he's going to get... So first he's going to check which one of these is bigger. So I guess we're going to do the same, like const larger is equal to the maximum of a value, b value. Smaller is equal to the min of those two things. And we are going to get a is equal to smaller and b is equal to larger, which means that probably we need to, like, in here we're going to have like a make node pair from a node ID and b node ID, which sorts them. That's going to kind of like do this. Right? Cool, which means that here we're going to say like costs get make node pair AB. There we go. Or else 1.0. All right. Then we can put cost. And this is going to have the cost as an F32. And this is just going to be put cost. Boom, 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 boom. All of that work just to say hash map. Blaze it. Fucking stupid. There we go. Okay, sure. All right. App. We need our node costs. So this kind of goes away. All this stuff that we were doing over here, fuck this shit. Boom, 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 boom. And instead, here, we will just store the node costs. So node costs is a node map data node cost multiplier map. And then here we have const node cost is equal to a map data node cost multiplier map dot init with our allocator. Error defer, even though it doesn't matter, just in case. And here we have node costs is equal to node costs. All right. All right. So now when we like on what is it called? We have a function where somebody asks us to monitor the weight. Here we go. Here we go. Here we just have to basically rip through that shit and rip through all of the nodes associated with the monitored way and append it to our cost multipliers. So this is fix me dedupe with render shut up. This is the way k way v And this is now just if this equals KID here is what we called it. And this is a VID. If this is true, then we have to add the cost. Oh, so this actually goes not here. This goes on set cost. Set cost. So in index zig right now, I guess is where that is. And here we will say, fix me, this belongs in app for sure. But you know, we'll get there. We'll get there. So we iterate over all the tags. We check if this is related to the ID. So we have attribute, you know, data. Jesus, I don't know, man. Is this thing, you know? And this is like data.k and data.v, right? Because these are the string table IDs. Yep. Uh-huh. If we find it, found is true and we break. And if found, we update the multiplier. So this is like app node costs. We get the current cost, which we actually don't just do this for the way, we have to do this for all nodes in the way. So here we say like global app ways get value is equal to I, which is a little silly. We should do something else, but that's okay. What does this give us? This gives us a bunch of node IDs. Node IDs. So here we kind of iterate for 0 to way len minus 1. We have the like pair is going to be like A or B is node ID. Fuck. Can we just use I here? No, J. Fuck. Okay. A is equal to way J, and B is equal to way J plus 1. So we have our 2 point IDs now. We get the cost of A and B. And now we set the costs to multiplier over the original cost, right? So if the cost, is that true? No. Because like before, I was trying to figure out like before they might have a cost of like we might have a cost of like 1.1, and we're setting the cost to we want the cost to be like 1.2 now. So we want to like multiply the. Yeah, we just put the multiplier, I guess. And fix me. Multiplier might be made up of more than one attribute. But you know us. We say that's a problem for future me. Because I do want to just see something right now because my brain is fucking melting, dude. It's so melt right now. And you can tell because I just said my brain is melt right now. That's how you know it's bad. Jeez, man. Okay, so we push this cost. And so now our path planner, he needs to like take in these costs, right? So he's going to say, hey, I want to know node costs is a const map data node cost multiplier map, which we must stash somewhere. Node cost multiplier map. So then we just store that here. And then when we calculate our scores, we add self node costs get, which now can't be done with a const pointer, I think, because I think we set it to, oh no, we're chilling. Although this almost certainly needs a non-const pointer. So here we just put in current.me and neighbor.me. And we get the distance times the node cost. I mean, I'm not like 100% against it. Now we have like certainly just a billion fucking issues to fix. Uh, 222, he needs the self node costs. Field missing get at 194. Yeah, that's true, because it would get cost. Way.len does not exist at index.zig181. So is this, what the fuck is a way? Like, I'm gonna lose my mind. Ways has way lookup, which is a way, which has node IDs. All right. I don't know why this isn't autocorrecting, but fuck it. F32 ignored at 185 because put cost returns something for some fucking reason, which it doesn't need to. Error unit is ignored, so this needs to try. This returns an error, which means that this has to write try, which means that this returns an error. Catch panic. Cannot set cost multiplier. Fine, whatever. Put cost. We probably didn't save this, so it doesn't know. And maybe, I mean, there's like a non-zero chance that this works. I think the chance is very small, though. Very small. Because nothing feels right. Nothing feels right. I'm tired. My head hurts. But it's okay. Okay, let's just start with saying that like we really like bike routes or something. Okay, so we love bike routes. Okay, so I want to get from here to here. Right? We want to take the bike route as far as we can. Okay. I mean, that's not working. Right? That's not awful. Okay, everything is slow as shit. Okay, so that part's awful. But like, you know, let's say that we want to get from like here to here. Oh my god, it's so hard to see anything because I wish I didn't have this tied to the center. I also wish that we could save the path without us like having to like I wish that I could like store the location or something. I'm trying to think of somewhere where going an extra distance, right? So like if I say I want to go from here to here, and then I look at like debug path planning. Okay, so here he doesn't even know that. I wonder if I can like make him kind of go a path he shouldn't by doing this. I think that lowering the cost here is actually never correct because lowering cost, the heuristic for how do I say this? The like heuristic for which path should we take, or like which node to look at next, it needs to underestimate. And so if we lower the cost of these other things, then like it can't accurately determine that. So we actually need to, it's actually better to raise cost. So let's try raising a cost somewhere. Sunk cost fallacy is real. So maybe let's say, like, what if we just say fuck sidewalks, right? We want sidewalks to be, you know, orange, and we want their cost to be 2.0 or something, right? So now if I try to walk from here to here, it should prefer to go on the road, even though the sidewalk is the fastest path. And it has successfully done that, right? Like if I go 1 here, it knows that I should walk along the sidewalk. But if I say 2, it decides like, okay, fuck sidewalks, let's go on the road. So we can pretend that I'm a car. And now when I walk through here, we should see him kind of like zigzag between orange lines as much as he can, which I do think is working, to be honest. It's slow as shit, right? This is like absolutely unbearable. But maybe if we reduce the turning cost, that'll help a little bit. This is unbearable, but I think it is working. Holy moly, what's so slow? I think it's probably like our storage format for the cost is probably really bad. I think probably we need to find a way to get rid of that hash map. That would be my guess. But who knows? That is going to be something that we look at tomorrow, I think, because this was harder than I thought it was going to be honest. I thought that we were going to get there faster. Are you recalculating every frame? Yeah, it's fucking stupid. There's a lot of stupid going on here. I would like it so that the path planning can happen within 1 frame. I also realized recently, actually, that what I realized recently is that given a starting point, all movements here are actually using the same graph. Right? So what we can actually do is we can store the path plan. We can like construct a new path planner when we say start path planning. And then as we move around, I think that we can just reuse the same scores, and that should become like way, way, way faster. I just haven't done that yet. Also, the rendering of the sidewalks is very slow because we aren't like doing one shot on the GPU draw all these things. We're kind of iterating them like every frame, which is fucking stupid. So there's a lot of stupid going on here, for sure. But I think I'm happy with seeing some progress. The fact that we are dodging sidewalks here is like that's a very good sign. It means that like at the very least, we're like resolving from like pairs of node IDs to tags correctly, which is actually like a non-trivial connection. So I think we call it there. It's 3:54, so almost perfectly on time for stream today. Thanks for watching, guys. If you liked what you saw, we stream most days at around 12:30 Pacific time to 4 o'clock Pacific time. If you're watching on YouTube, you're seeing the 2 to 4 segment, which is, you know, dinner time, yum yum. But if you want to see some of the like less intense, more like, you know, focus on like cleanup and hanging out and stuff like that, there is happy hour from 12:30 to 2 Pacific time most days. They're archived on Patreon. If you're watching on Twitch, you should check out the YouTube. There is all of our previous work organized into playlists. So if you want to see like operating system, QR code decoder, zlib implementation, video editor, Rube Goldberg machine, there's like lots of fun stuff in there if you want to go check it out. There's a GitHub link in the Twitch description where code for this will end up on, you know, over here somewhere, but there's also code for all the other projects. So you can check that out if you want it. There's a Discord link in the Twitch description if you want to get announcements for when I go live and stuff like that and talk about shit off stream. spheriphoria.dev if you want to contribute to the thing in the side. You can create your own WebAssembly module, upload it to the site, and it is very likely that I will accept it. Here is a funnel by TortTube. Oh, that's kind of fun. So it's kind of like trapdoored. We'll accept it right now. So if you want to do that, look, now there's a trap. Now it's right here. Look at that. That's kind of fun. I think that is everything we have to plug. Like, subscribe, Twitch Prime. You guys know the dealio. And I'll catch you guys on the next one. Bye, YouTube and Twitch. Let's find someone to raid.